And today I was working on just trying to make everything a little bit cleaner and lubrication, and then getting everything nice and square. So the lube we have here is Mobil Velocite oil number 6, because 1 through 5 wasn't good enough, so it has to be number 6. And pretty much just dump that right in top and let it flow through. I tried to fill up these sort of special lubrication points up here, which did basically nothing but overflow. So dropping it in from the top seemed to go through the whole spindle and lubricate everything, which was good, including the quill assembly as the quill comes out, so that got nice and lubricated as well. Interestingly enough, after that lubrication, this darker, nastier oil is kind of coming out of it, so I'm wondering if the previous owners of this mill had put sort of motor oil or gunky oil in it, or that could just be oil that's been sitting. You see these little oil spots here, that's the spindle oil, the new spindle oil, the Velocite oil, and this is what's kind of just dripping out. So whatever's in there is a little nasty. We didn't get this on video, but there was also some really nasty oil that came out of the ways as well, and we replaced that with Mobil Vectra oil number 2, and that seemed to help everything smooth out a little bit. We also have the VFD in RPM mode, so this is the RPM of the motor. And there's a gear down in here as well, so it doesn't take into account that gear down. I have to figure out what ratio that is. But it's actually probably just sitting on that nameplate, but I just haven't really sat down and read it yet. But it's kind of nice just to see the actual motor RPM rather than just the hertz. So, and we also tightened up the response, so the RPMs of the VFD actually follow. I got another mosquito bite. The RPMs of the VFD, or the RPMs of the motor, follow the VFD control a little closer, so you get sort of more nicer immediate control, which is kind of cool. Also worked on squaring everything up, so the head is now square about the y-axis, and also the x-axis here as well, and it was wildly off because it had never been done while it was in my ownership, and I've done nothing but move the head around. So it needed to be aligned, so everything is square within a thousandth or two, so definitely square enough to do something reasonable. And the vise here is square within plus or minus 5/10, so a total of 1/1000. So the vise is very square. It's as square as probably the mechanical limits of the machine will allow it to be square. So that's pretty cool. So that can actually cut something. Another issue that was going on, and I'm sure you're enjoying the lovely lighting situation, but there's a power feed system here. And this power feed system was having a little bit of a mechanical issue, because here on the, I guess, axis ball joint here, or axis rod, there was a Woodruff key which was trying to key the this handle and all these extra fiddly bits, including the assembly which interfaces with a gear in here to actually drive this shaft. Yeah, that Woodruff key was completely missing. So this was set up with this bolt, or this nut here, just in sheer compression, and it was transferring the gearbox here was transferring torque to the shaft just by pure friction of being smashed together, which was obviously very bad. So I ordered some Woodruff keys on Amazon, found the one that fit, and put it in there and press fit it with kind of, the hammer just kind of tapped it in, and now it works as it should. And now you can use the axis like a human being, and there's not like a ton of resistance on it or anything. It has an appropriate amount of resistance for, you know, what it should be. And also now this crank actually works correctly, which is nice, and the power feed works, which is brilliant. I've worked on some Bridgeports in the past, like at school and whatnot, and I've never worked on one that had a operational power feed. So I was pretty happy to get this working, because this is just all sorts of convenient, especially when you want to move the table over this way so you can get to the other side of the garage. So that's pretty awesome. The one thing that this guy still needs is there's a little potentiometer down here, and the potentiometer needs to either be cleaned or replaced, because it goes from 0 to 9, and it's off, and then on. And then after that, it makes no difference. So something's going on with that little potentiometer in there. So it either needs to be cleaned or replaced, but that's okay. That's pretty minor overall. The other thing that we need to be doing is this guy. This, I guess, lever used to live here to operate the quill, and you'll notice it's missing the pin in there, which actually interfaces with these wonderfully lit holes here. So I need to figure out what size pin that is and get one of those, but that's not really a big deal either. I figured out how the power feed works by pressing this in. Well, first we actually have to enable it. You have to move this guy over. Of course, it does it while it's on camera. There you go. You move that over. Now we have this spinning. So you can get just a little bit more light. Doesn't have to be the surface of the sun, but at least we get some more here. So we can control which way this is rotating by pushing it in, pulling it out to a neutral position, or pulling it all the way back. And that gives us our 3 positions there. So one of these directions will actually move the quill down, and one of them will move the quill up. I always forget which one. I think... So we pull this other lever out to engage it, and it's moving down slightly. It'd be hard to see, but I can speed it up a little bit here, which is part of the joy of the VFD. So yeah, you can see how that's coming out. And that's moving faster or slower, which is pretty cool. So you can disengage this, push this in to have it move the other way to retract, engage, and pull it back in. Then when it gets to the end, it'll there's a little release clutch, and it'll just kind of slip a little bit. Yep, there you go. So that click is it being all the way up. So even though that this handle isn't set up yet, you know, we still have control over that quill axis, which is definitely an important feature of the machine. And then just to be nice when I'm not using it, I try to keep this in neutral and then disengage it up here. I mean to look up the serial number, but I haven't done that yet. It's J209987. So whatever that happens to be, I'm sure there could be something on the Bridgeport website of what it was made. I believe this machine is what is referred to as a J head, which is kind of funny because of my name. So yeah, I looked at some pictures of quote-unquote J heads online, and there's some extra stuff that's on here that's not really on here. Like there's usually like a big handle on here. I think there might be something that goes in here, but I'm not sure. These 4 bolts just hold the head on. But there might be some accessory stuff. I still have a couple extra parts in my parts bin that I got off of this machine when I originally moved it, and I'm not 100% sure where they go. They're just like little handles and things, but as far as I can tell, all the control surfaces and mechanisms are present. So I'll have to look at some more pictures and documentation to see, you know, where all that stuff goes, which is cool. It also has a nice little magazine over here, which is just like a little 8-position. Again, I understand this is hard to see, but it's a nice little multi-position holder there for R8. And I have another little machine that also takes R8, and it came with this as its primary spindle tool. So I just put that in there for now, just to be amusing. Let's see. Other interesting things about the mill. Oh yeah, it has a little squeak in the Z. Let's see if we can get it to squeak. It likes to squeak on the way down, and of course it's not squeaking for you, which is I guess a good thing. If we go up a little bit, just moving that, moving that, moving that. There you go. Hear that? It does that going on the way down, and I'm not sure what that is. Spraying WD-40 on the, I call that I'm not sure if that would be called the W-axis or the Z-axis. It depends on if you want your quill to be the Z-axis or you want the table to be the Z-axis. But yeah, the ball screw, or not the screw, but the lead screw that's under there, if you spray that with WD-40, the squeaking goes away a little. And I'm not sure if that means if something needs to be replaced or something's just mislubricated. So I just try to move the W-axis gingerly, or Z-axis gingerly, until I can figure out what that is. Let's see, we're still dripping gunk out of the spindle. We can conveniently power feed it back over so it'll drip on the paper towel. So that's pretty much where it's at. It can cut as it is because everything's square and the spindle works and the axes work. It's just a little inconvenient not having full access to the quill because this part isn't hooked up all the way. But yeah, other than that, it should be ready to cut. So, I guess while we're at it, might as well go look at the rest of everything. So this is a Smithy 622, and I got this off of a guy in Western Illinois, and I think it's like a 1 horsepower spindle-ish. It's full CNC, it's Linux CNC variant. It'll do like 90 inches per minute on the X, Y, and Z axes. I'll make a video about this at some undetermined point in time. But it does work, and that's pretty cool. So these two machines are both fully operational. So that's 2 operational machines. Plus I have a Pocket NC, which is currently sitting at work. And that's a little mini 5-axis desktop machine, which is pretty cool. So I have 3 operational machines. So these 2 machines are going to work on finishing this machine, which is the Millinator. So the Millinator is actually doing better than it looks. So we had basically got 3-phase working here by going from 240 into the VFD to make 3-phase, and the VFD does VFD things, connects to the motor, and life is good there, right? So we've successfully proven that we can go from 240 single phase to a 3-phase motor, which is incredible because that's going to allow this machine to actually run properly. So the that's a big umbrella changer up there, which is, there's like a little servo that runs that. But the big thing there is the axes. I want this machine to have at least 5 horsepower, which is going to take most of the power that goes into the garage when that happens. I have some custom brackets that I've had made by my buddy who at the time worked at Google, and he made those in the maker shop up there that Google has, and those will adapt NEMA 34 or NEMA 42 motors to the axes. So that's extremely convenient to have those already made. And then that's on the top right there, that's where the Z-axis ball screw goes. You can't really see it right now because it's obscured by the umbrella, but behind that, that's where the spindle mounts, where the spindle motor mounts. So currently working on getting like a 5 horsepower 3-phase spindle motor, and the VFD that's currently sitting on here is a 7.2. Yeah, it's a 7.2 kilowatt VFD, and this VFD that's over here will eventually go power the mill spindle. But for now, we just were proving it out here on the Bridgeport. Eventually, the Bridgeport will get a new VFD that's in the same product line, just the smaller 2.2 kilowatt model, because that's all it needs. And then this guy will migrate over there, and then life will be amazing. And then, yeah, let's turn this off here, and we can go look at the one other machine. So over here, this is the compressor, which works, and I was just playing with some of the controls in there to try to make it do more of what I want it to do. And this is another machine, and this machine is a machine that was originally a manual mill, like a tiny manual mill, but there were CNC kits for it, and who could say no to that? And so I wanted to make this little unit a little CNC unit. The Smithy kind of replaces this because the Smithy is bigger and more powerful, but I still want to finish this because I think it's kind of cute. So yeah, there's the reason why this machine isn't done is there is a, I don't want to say a manufacturing defect, but there was an engineering change or a manufacturing change to the base casting of where the Z, this is the Z plate here. There was an engineering change, and I need to basically make a very precise hole right there, right in the middle of those. And now that I have like 2 operational mills, I can totally do that. And once that gets operational, I can put the motors and controller on here. I have ClearPath motors for this, and I think they're 34s, which are definitely overkill, but that was kind of the point. Because I wanted this to be kind of like light and fast, so the motors are kind of more powerful than they need to be, which will be kind of fun. I also designed a 2-axis trunnion for this, so at some indeterminate point in time I can build that and turn this into another mini 5-axis machine, which will be pretty sweet. And Linux CNC does have provisions to run 5-axis. There's something called a 5-axis KINS module for kinematics, and you can get stuff like tool center point control and plane matrix set up with that. Some people have done that on the internet, and that'll take a little bit of work to do on the software side, but I'm not too worried about it because it's already been done theoretically. But yeah, once the Z-axis ball screw thing, once this gets back onto that, then we can continue with that project. This is another little motor that I got as a gift or a surplus from Heidenhain. It was literally in their trash bin, and I kind of asked if I could have it, and they just gave it to me. So chances are it still works. I just haven't played with it. Let's see, does it say how much power is on it? 3.3 Newton meters at 5.4 amps, 4,000 RPM at 180 volts. Oh, the max is 4,000 RPM at 180 volts at 25 amps. So whatever that turns out to be. I'm wondering if it's just the control box is bad, but the actual motor is probably good, I would imagine. So I can look that up and play with it. This is a generator. My friend gave me this generator, and it's 5,500 watts, and it'll do 8,500 watts for starting, which is pretty nice. The idea with this is that if the mill draws too much power, then what we might do is use the generator to power the axes, or use the generator to power the spindle, and then the house will power either the axes or the spindle, so they'll be completely split. So the generator will basically run half the machine, and the house will run the other half of the machine if there's not enough power. So All those are pretty nice because doing it this way requires no modifications to the house, which is important. Yeah, so just kind of a view of the inside. Of course, the lighting's not so great. This probably would be better during the day, but you get the idea. You can see the ball screw in here, and there's mounting plates. So the custom plates go there, which is pretty rad. So, and there's just kind of the back shot of the machines. So that's kind of where everything is at the moment. So we'll just keep chugging on stuff. We'll keep improving this mill. This mill's fine. We'll eventually get to doing that mill, and then this guy's getting a spindle, and that will greatly move things along. So this has been a little rambly, but I hope you've enjoyed it. So I will be signing off now, and have a wonderful night.